In today's lesson, we are going to talk about polynomials. We're going to talk about what is a polynomial, and we're going to talk about the key parts of it and some specific names for different kinds of polynomials. And then we're going to end with adding and subtracting polynomials. So our essential question, what is a polynomial and how do we identify its key parts? And our second essential question, how do we add and subtract polynomials? So a monomial, that prefix mono, meaning one, is a number, a variable, or a product of numbers and variables. So for example, 6xy squared is a monomial. So anytime we're just talking about things being multiplied together, we have a number 6, we have two variables x and y, and even though y is being squared, this is all one term, so to speak. A polynomial is a monomial or a sum of monomials, meaning that it is multiple terms. Each monomial is called a term of the polynomial, and those terms are going to be separated using addition or subtraction symbols. So a polynomial could be something like 6xy squared plus 2x plus y plus 5. Let's make a minus x squared, something along those lines. Poly meaning many, it could have many terms, and again, each term is separated by a plus or a minus symbol. So this polynomial has, let's count how many terms, 1, 2, 3, 4, 5 different terms. So a monomial is just a specific type of polynomial. A monomial is a polynomial that only has one term. And there are a couple of more special types of polynomials as well. If a polynomial has exactly two terms, it's called a binomial. The prefix bi, like bicycle, meaning two. So if I had, let's say, 6x squared plus 5, that plus sign is separating two terms, which is what makes this a binomial. A polynomial with three terms is a trinomial. Tri meaning 3. So this could be something like 6x squared minus 5x minus 7. 3 terms, each being separated by the two negative signs. So what I want to make sure that you understand is that a polynomial, each of these are types of polynomials. So a polynomial, if I made like a little mapping here, a polynomial is the big thing. There are different types of polynomials. There are monomials, there are binomials, there are trinomials, and there are just other polynomials which have more than 1, 2, or 3 terms that we just call still polynomials. But a polynomial is broken up into these categories. If you think about it, I drive a Honda. Honda is like the term polynomial here. It's the name brand for everything that falls into that category. But within that, there are CRVs, there are pilots, there are Accords, there are Civics. So each of those subtitles is like another category here. So all of these things that we're talking about are called polynomials, but some of them have more specific and specialized names. So now that we know what a polynomial is, let's talk about some more specific things that apply directly to polynomials, some more in-depth vocab. So right down here, we have a polynomial that has 4 terms, so it doesn't have a special name, it's just a polynomial. And within that, there are some other things to talk about. So the leading coefficient is that number in front. So the leading coefficient here is the 2. It's the very first number in front of the term with the largest exponent. And that exponent is called the degree. So the degree of this polynomial is 3. The degree of a polynomial is the greatest degree of its terms. And a polynomial is in standard form when it is written in the order in which all of the variables all of the exponents, all of the degrees go from largest to smallest, and that is called descending order. And the last word I just want to briefly remind you of, it should not be new, but is a constant. A constant is a term that doesn't have a variable. So in this case, this polynomial with 4 terms has a constant term of 12 because there is no x or y or any other variable connected to 12. That was a lot of vocabulary. So what we're going to do right now is we're going to look at some examples and really identify the different parts of vocabulary from those examples. Okay, so for these next 3 examples, we're going to find the degree of each polynomial and classify it. We're also, it doesn't say this, but we're also going to identify the leading coefficient and make sure that it's written in standard form. So number 1 is only one term, and that makes it a monomial. That monomial, since there's only one term, is obviously already in standard form. I'm going to use LC to represent leading coefficient. And the leading coefficient is that number that is in front of the first term when it's in standard form, which in this case is -3. And the degree is going to be that exponent with that leading term, which is 4. So this -3x to the 4th is a monomial with leading coefficient -3 and degree 4. Okay, let's look at number 2. Number 2 is not currently in standard form, and I can tell that it's not currently in standard form because standard form means that the highest exponent comes first. So if I look at each of those 3 terms, 1, 2, 3, and because there are 3 terms, I can categorize this right now as a trinomial. I want to rearrange those 3 terms so that the one with the highest exponent comes first. Well, which has the highest exponent? 5x squared. And which has the next highest exponent? Well, there's only one more term that even has a variable, so that's going to come second. And our constants always come last. So now this is in standard form because it goes to second degree, first degree, no degree because there's no variable. That puts us in standard form. So let's identify our other 2 parts now. Now that this is written in standard form, the leading coefficient is going to be that number in front of our first term, which is 5. So our leading coefficient is 5. And the degree is going to be that exponent in the term that's now in standard form, which is 2. So our degree is going to be 2. And remember, all of these are polynomials because poly just means many, many terms. So a monomial is a polynomial, a trinomial, a binomial. If there were 8 terms, if there were 10 terms, they're all still polynomials. So what I want you to do on number 3 is identify the type of polynomial if it has a special name. If it doesn't have a special name, it's just called a polynomial. I want you to make sure that it's in standard form, and if it's not, go ahead and put it in standard form. And then answer those 2 questions. What is the leading coefficient and what is the degree? So go ahead and pause the video and work through that last problem, that you do number 3. Okay, well, this has 4 terms, so it doesn't have a special name. So it's just a polynomial. And all 3 of these, remember, are polynomials. It is, in fact, already in standard form because if you look at those exponents, they go 3, 2, 1, no exponent because there's no x. So it is already in standard form. So the degree is going to be that highest exponent or that exponent of the first term. So my degree is going to be 3 on this problem. And the leading coefficient is the number in front of that first term. And if there's no number written there, remember there's always an invisible 1. Ooh, let's make that look like a 1 though. An invisible 1 there. So my leading coefficient is 1. So the nice thing about standard form is that it really helps us identify the key parts, degree, leading coefficient, and in future chapters we're going to need things to be in standard form in order for us to use things like the quadratic formula, in order for it to be easier for us to factor. So standard form is something that's really important in helping us identify different parts. The last thing that we're going to do, now that we know a little bit about what a polynomial is we're going to see how it functions. And some of this might seem like a little bit of review, and that's okay. We're just going to talk about how do we add and subtract polynomials together. So what if I had to add the part in number 1 I do and number 2 we do together? What would I do? What would that look like? So when we are adding and subtracting polynomials, what we are really doing is we are just combining like terms. And remember, like terms have to have the same variables and the same exponents in order for us to combine them. And when we are combining them, we are not changing the exponents. And we're not changing the exponents because when we're adding something, we're just counting how many of them that we have. So if there is an addition symbol, you're simply going to combine the things that have the same variables with the same exponents. If you are subtracting, there's one additional step. What you're going to do first is you're going to actually distribute that negative sign to the entire second term, and then you're going to combine like terms. So let's do that first. I'm going to leave this first set of parentheses the same, 3x squared minus 2x plus 7. I'm going to distribute this negative, so negative x squared minus 5x plus 12, right? When I subtract a negative, that's going to become positive 12. And now I'm going to combine like terms, and I really like to do this with different colors so you can see. Here I have 3x squared. Do I have other x squared terms? I do, this one right here. If I combine 3x squared and negative x squared, I get 2x squared. So I'm counting. I had 3 of something. The something I had was x squared, and I'm taking one of that x squareds away, so now I have 2 of them. Similarly, if I combine my x terms, negative 2x and negative 5x, I have negative 2 of something, and I lose another one. I now have negative 3 of that something. And lastly, with our constants, which we have been doing all year, I have positive 7 and positive 12, which is going to give me 19. So to write our final answer, after we combine like terms, we're going to write it in standard form. 2x squared minus 3x plus 19. So again, if you're adding, you're just combining those like terms together. If you're subtracting, then you're going to go ahead and distribute that negative sign first, and then you're going to combine like terms. And we want to make sure that our answers are in standard form. So let's look at number 4. On number 4, we're using addition. So we can basically, based on the commutative property, we can ignore all those parentheses. They're not doing anything, and we can combine the terms that are alike. So negative 2x to the third and positive x to the third. I have 2x to the third and one more. That's going to give me 3x to the third. I have negative 5x squared and positive 2x squared. Negative 5 and positive 2 gives me negative 3x squared. I have an x, and in the other polynomial, I don't have anything that has an x, so I just still have an x. And lastly, I have negative 1, and there's no like terms, no other constants to combine with, so minus 1. So this is the polynomial that I get when I combine like terms, when I add those two polynomials together. Okay, number 5. We're going to distribute first. So I will have 4n squared plus 5 minus negative 2, so that's going to be plus 2n squared, minus 2n plus 4. So the very first thing I did was distribute that negative. Now I'm going to combine like terms. I have negative 4n squared and 2n squared. That gives me 6n squared. I have positive 5 and positive 4. That's going to give me 9. That's my constant, so I want that to be at the very end. And I have negative 2n and nothing to combine with negative 2n, so it's going to just stay as negative 2n. So when I take this binomial, 4n squared plus 5, and I subtract negative 2n squared plus 2n minus 4, that trinomial, I end up with the polynomial 6n squared minus 2n plus 9. Okay, go ahead and pause the video and work through 6 and 7 on your own. Okay, number 6 is addition. So I'm just simply going to combine like terms. So I have 3x squared and x squared. That's going to give me 4x squared. I have positive x and positive 4x. That's going to give me 5x. Because remember, I'm just counting how many I have. If I have 4 x's and then I have one more, I now have 5 x's. And lastly, I'm going to deal with my constants. This is a negative 6 and a positive 10, so that's going to give me positive 4, since 10 plus negative 6 is positive 4. So the sum of these two trinomials is this trinomial. Last but not least, number 7. is subtraction. So the very first thing I'm going to do is distribute this negative. So 6x squared minus 3x plus 5 is going to stay exactly the same. But over here, I'm going to subtract 3x squared minus negative x, so plus x, minus negative 8, so plus 8. Then I'm going to combine like terms. 6x squared minus 3x squared. If I have 6 of something and I take 3 of it away, I now have 3x squared. Negative 3x and positive x is going to give me negative 2x, negative 3 plus 1. And lastly, 5 plus 8 is going to give me 13. So when I subtract these two polynomials, I end up with 3x squared minus 2x plus 13. So the last thing I want to do, just to wrap this up, is give you some helpful reminders when you're working through these problems. Okay, so here are my helpful reminders for you. First of all, always use standard form. Always make sure that your final answer is written in standard form, meaning the highest exponent on the far left going down to the term that is constant or that has the lowest exponent. Second, always distribute first. When you're adding, you're just distributing 1. So really you just get to remove those parentheses. But be careful when you're subtracting. Make sure you distribute that negative and watch out for the double negative situation when you're multiplying a negative by a negative. Go slow. Sometimes we try and go really quickly through these problems and then we make careless mistakes. And then lastly, don't forget that what we're doing is adding or subtracting when we're counting how many of something that we have. So we're not going to change the exponent. When we start talking about multiplying, we are in fact going to be changing the exponent. But when we're adding and subtracting, we're simply combining like terms. So thinking back, our essential question was, how do we identify what a polynomial is and its key parts? So we talked about terms, degree, leading coefficient, standard form. And then how do we add and subtract them, which we just talked about here. If you still have a couple of questions, make sure you write them down, and looking forward to supporting you on this in class. Thanks for listening.